Um, Hello everyone, my name is Zahid Sheikh and I'm Oracle DBA and Architect. Today's presentation is on some of the Oracle's 12c's new features. The presentation is two-part. First part will cover new features for developers, or some of the new features for the developers, and second part will cover some of the new features for DBAs. So let's begin, but before I start, I want to go over some of the architectural changes with Oracle 12c database. If you look at this slide, this is sort of in high-level architecture. So on the left side, you have existing database architecture, and on the right side you have Oracle 12c multi-tenant database. If you look at on the left side, so all these five databases, let's say they are on one server, and what will happen that each database instance will have its own background processes and memory structure, versus on the right side, if you look at it, the concept for Oracle multi-tenant architecture is that you have one container database, and within that one container database you can create multiple pluggable databases. So basically, in essence, then you will have only one set of background processes and one memory structure, which is the SGA, for all of the databases. So that's the main difference between Oracle 11g architecture and 12c multi-tenant architecture. This slide kind of depicts that you have one container database background processes, and then you have multiple pluggable databases underneath that container database. So all the tools, metadata repository, and seed database resides at the top level, and this is sort of giving you further depiction of the new architecture. So again, you will have one SGA, which is a memory, and one set of background processes, and then you have one root container, and now you have multiple pluggable database under that root container. The main difference, if you look at it, when you need to patch or upgrade, with the older architecture, you are patching and upgrading all of the databases within that server, versus if you have a pluggable, the multi-tenant architecture, where you have one container database and underneath that you have multiple pluggable databases, then all you have to do is just patch and upgrade the container database, and then in essence all the pluggable databases will be patched and upgraded. So you do not need to do it individually or separately. Now let's look at 12c new features. So there's so many new features with Oracle 12c, but I've highlighted here a few of the top 10 ones. So for the developers, you have invisible column, multiple indexes on the same column, limiting rows for top-end query results, sequence as a default value, identity type columns, then you have extended data types, truncate table cascade option in 12c. There are some miscellaneous SQL Plus enhancements, and there is a new function called approximate count distinct function, and exporting views as tables. And I'm going to go further on the details on some of these new features. Now look at some of the new features for DBAs, online migration of an active data file, DDL logging. You can now execute SQL statements in RMAN, restricting PGA size, SQL loader expert mode. That's a neat feature too. Data pump enhancements and database caching, disabling the logging for import, and also recovering tables from RMAN backups. So the first part of the presentation is solely going to go over on new features for Oracle developers, and then the next part is going to be on new features for DBAs. So let's look at it. Let's look at 12c new features for developers. Invisible columns. Oracle introduced invisible column concept in 12c. Now in 11g you had Oracle introduced invisible indexes. So now in 12c it has introduced invisible columns. Some of the characteristics are when you define the column as an invisible, it will never appear in your generic SQL statements. So when you insert values into the invisible column, you must explicitly refer to the invisible column when you're doing insert. And I'm going to show some of the examples so you are clear on how it works. Now, what are some of the benefits? Now, previously, when we needed to hide a specific column, let's say for example the sensitive data for salary sensitive is sensitive data, right, or date of birth or social security number, and we so in order for us to hide those information, we used to create views and then without those columns off of those tables. And also other benefit is that, you know, when you do select all and you don't want to show that column in your generic queries, and then the invisible column will not show. So, you know, there's some great benefits to it. Now let's look at some of the examples. So I'm just creating a simple table called employee with 3 columns: employee number, name, salary, and I'm making salary as an invisible column. So when you insert into employee, you explicitly specify the salary column when you're inserting a value. So in the first example, when you say insert into employee, employee number, name, salary, values is 1, Mike, and 7,000. In the second record, when you insert it, and if you don't specify the column, the value will not be inserted into the salary and it will not error out. But if this is 11g and you try to do this insert employee values only inserting into the employee number and employee name, you will get an error. So now if you do select star from employee, you're only going to see the number and the e-name. But if you want to see the salary column, you have to explicitly select the salary column from employee table. So when you look at this SQL statement, you will see the salary, but you have noticed that there's no salary for John. And the reason there's no salary for John, because when you inserted a second record into employee table, you did not specify the salary. Okay, so these are the few of the examples. Now if you need to modify a column to be invisible or vice versa, you just simply, you know, use the following alter table statement: alter table employee, modify salary visible, and the salary column will become visible. But now, interestingly, if you want to show your invisible column, you know, in your description, how would you do that? So there is a SQL plus command called set column invisible on and off. Now if you turn it on and then you do describe, then it will show all the invisible columns in that particular table. However, keep in mind that this will not affect anything for your select statement. So when you run the SQL query without salary column, if you just select star for all from employee, then it has no effect. It will be the same. You will not see the salary column. So by setting column invisible to on, it will only take effect when you do the description of the table. Multiple indexes on the same column. Now in 11G, as I mentioned earlier, that Oracle came up with this invisible index concept, but with 12c, in addition to the invisible column, it also will allow you to create multiple indexes on the same column, which you are not allowed to do in Oracle 11G. So for instance, if you have a column or a set of columns that you want to create two different indexes, you couldn't do that. But in 12c now it will allow you to create multiple indexes on the same column, as long as index type is different. That is, if you already have a BT index, you can only create a bitmap index or function based index or a unique, etc., etc. So two different, you need to create two different types of index, and only one type of index is usable or visible at any given time. Now in order for Oracle to use that index, the invisible index, you need to turn on the following parameter. The parameter is optimizer use invisible indexes to true, and by setting this, then only optimizer can use this index. So let's look at an example. So in this example, I'm creating a table called my tab, and I got 3 columns. Then I'm creating an index on XY column, and then now this is the B tree index. So now I'm creating a bitmap index. Now if you look at it, you will see the error. It will tell you that such a column is already indexed. However, the reason you got an error is because you did not use the keyword invisible. So when you create a second index on the same set of columns, then you have to specify invisible. So now if you say create bitmap index, table name, index name, and on my table XY invisible, the index will be created. Let's take a look at it, how the optimizer uses the index. So I'm just setting it the auto trace on and showing you the explain plan. So if I do select count from my table where x equals to 1 and y equals to 1, if you look at the execution plan, it's using the original B tree index. However, if I set this optimizer user invisible index parameter, then Oracle optimizer will use the BT index. Why would you want to create different index? Well, it could be many reasons. Let's look at a couple of them. To test the performance of newly created index, you already have a BT index, and you want to test whether the bitmap index or any other index may perform better or not. So once you have tested your indexes and then decided that you want to keep either BT index or the bitmap index, you can go ahead and drop one of them. Just keep in mind that when you have a large table, creating and dropping indexes could take long. Well, actually creating index could take a long time, but you have already pre-built it and just made it invisible until you have decided that you're going to use that. I think it's a great option. Another new feature that Oracle 12c has is truncate table cascade. In the previous releases, when you have a parent table and then you have multiple child tables or grandchild tables, in order for you to delete a record from the main table or the parent table, you have to go and delete all the child records before you can delete the parent table. But now with the 12c, this has changed. So Oracle has introduced this cascade option. When you do truncate and use the cascade option, it will actually not only delete your parent record, but it will delete all other grandchild records as well. However, you have to use delete on cascade option in your foreign key tables when you're referencing the foreign key, and if you don't do that, then it will error it out. And the last bullet when says there's no cap on the number of recursive levels, as it will apply on all child, grandchild, and great grandchild records as well. Let's look at an example here. So basically, I'm creating a parent table with 2 columns, and then I'm creating a child table, and then the CID number is actually pointing to create a reference to the primary key in the parent table, and I'm using this on delete cascade option there. So once I've done this and then start inserting the record, and then I want to delete those records, all I have to do is simply say truncate table parent table cascade, and just keep in mind that you will see error 14705 if no on delete cascade option is defined with the foreign keys of the child tables. Now let's look at the row limiting for top end result queries. Now this option is available in 11G or previous versions. What 12C has done is actually had simplified by using some of the new options. For example, fetch, first, next, percent. So these are the clauses that now you can use, which has actually simplifies retrieving the top or bottom rows. With the previous versions, you may have to do slightly complicated SQL in order to retrieve the top or bottom rows, but with the 12C, it's pretty simple. So let's look at some of these clauses. Fetch first clause to retrieve only first few rows. Then you have a fetch next clause to retrieve only next few rows, and then you can also offset rows to skip certain end first rows in a result set before starting to return any rows. Also, you can specify percent size of the results set as a fixed number of rows. So as I said, that there are various indirect approaches and method exist that you can still use it in 12C. So let's look at some of the examples. Now, if you look at on the left side, this is 11G. Of course, you can do this 12C. So in order to retrieve top 5 salaries from imp table in 11G, or even existing 12C, you can do select star from, and then use a subquery select star from employee info order by salary description, where no num less than equals to 5. Now on the right side, if you look at it in 12C, all you have to do, say select star from employee info table ordered by salary description, and then say fetch first 5 rows only. So you can see the simpleness on the right side. Now let's look at some of the example. I'm creating this table called employee info, has employee number, department, salary, and headed. I'm inserting some of the data into this table, bunch of records. Now the first query, I want to retrieve the set of data. I want to retrieve top 5 rows sorted by its salary. So all I have to do is the same example as previously I showed to you. select star from employee info, order by salary, description, fetch first 5 rows only. So here, you know, you're going to see those top 5 salaries are displayed. Now, second example, I want to select query, list the top 25% of employees when sorted by their hire date. So I'm simply going to say select star from employee info, order by hire date, fetch first 25% rows only. All right. So if you so you got salary 25, 3,000, and this is sorted by hire date. Okay. Next example is there's an option with those different clauses. You can do with ties. So for example, if the 5th row has a salary of 2100 value and there are other employees whose salary matches with the nth value, they will also be fetched upon mentioning with ties clause. So this is how the syntax goes. So at the end, when you say fetch first 5 rows with ties, so it will actually bring another record. Now, in addition to 5 record, you'll see that 109 with the department 20 and the salary 2100. Okay, so the 5th row was 2100. Now there was another employee whose salary was 2100 as well. So you know, you could do a lot of different combinations with these different clauses. So now let's look at sequences supported for columns without triggers. As you know that in the previous releases, every time we want to generate a unique number automatically, we have to create the sequences and then use some sort of a SQL or PLSQL or programmatically populate those values, using the triggers. But with the 12c, rather than using the triggers, now you can create a sequence and then use that sequence as a default sequence for your primary key or for your columns. So let's look at the example. I'm creating a sequence named test sequence, and then I'm creating a table with 2 columns, ID and name, and I'm making ID as a primary key, but I'm defaulting to that sequence number. So every time I actually insert a value, it will generate a new sequence number in ID column. So if you insert into test table values, default Paul, and then if you do select star from test tab, you will see that the ID column was inserted by default. And similarly, if you want to do programmatically, then you could use the trigger as we used to do. So now there's no need to do this. You can use this feature within the Oracle table. Also, 12c has introduced a identity column. Basically, in addition to using a reference to a sequence to create a default column value, you can also use an identity type which will generate a sequence and associate their sequence with the table. Very neat feature. So basically, 12c features enables to define auto numbering for a column. The only caveat is that you can only generate one identity column per table. So let's look at the example. So the following will generate a sequence and associate the sequence with the table. So I'm creating a my table with 2 columns, X and Y, and I'm generating X as my primary key, but I'm generating as an identity column. So now when I insert into my table, I'm Zahid and then second column white. Then I do select star from table. The X values are generated automatically. So if you notice it, there is no need to create a sequence, you just create an identity column within the table, and then that's all pretty much you need. Also similarly, another example, just like you can define the sequence with the start value and increment by, you could do the same thing with the identity column. Basically this shows that you can control the start values and increment values. So if you look at the example, I'm inserting another value into my table, and then I'm inserting another value as a default, and then the third value as a word. So now if I select star from my table, you will see that the first value was added was 1, second value was 42 because my start value was 42, and then increment by 1000. So basically what I'm doing here is that when I'm inserting a first record, I'm putting a hard value, which is a 1 in the X column, but next insert statement I am using the default value because it defaults to, when I created the sequence, it defaults to, when I created the identity column, it defaults to start value 42 and then increment by 1000. So that's why you see second value as a 42, and then the third value when I'm inserting, you will see 1042 because it was increment of 1000, so plus 42. So next one is some of the miscellaneous SQL enhancements. YTOracle12c has several of them, but I just wanted to highlight the main one because I use this a lot, and I'm assuming that a lot of other folks use this too. The new function called return result basically returns the formatted results in SQL+. So let's look at an example, then I'll show you the difference between how you could do it otherwise. So this one, I'm just simply creating a procedure, myproc, and then I'm selecting the data from employee info table, and then if you look at the end, it says DBMS SQL return results. So when I execute my procedure, it will simply bring up all the data formatted and will be displayed on your command prompt or SQL+ prompt. So this is pretty easy. I think this is a really neat function. Now if you were to do it other than using this the return results, so on the left side, if you look at it, you have to kind of write a little bit more complicated code. It's not very complicated, but it's not that easy if you look at it on the right side. So without using the the DBMS SQL return result function, you have to kind of create a for loop, and then use DBMS output, and then on the SQL plus prompt you have to set server output on, and then when you execute, you will see the desired results. Versus on the right side, all you have to do, simply do the select from the table, and then pull the results using the return result function. Pretty straightforward. New extended type feature also with 12c. Currently, as we know in 11G, with the YTOracle12 or YTOracle12 and raw, it only supported 4,000 characters or 2,000 in earlier releases. But now with the 12c version, it can go up to 32,767 bytes. So essentially, the extended character size will reduce the use of going for lob data types whenever possible. Now, in order to use those extended data types, you have to modify or add this max string size a parameter, and needs to set to extended, and then once you set that, you need to bounce the database. So you know, with the current versions, I mean, it's I have not seen any issues with it, but it could potentially cause the issue for the existing length for the existing data types, because it may get confused after you do the extended string size, if you set that to extended. So you got to test this out carefully to not to you know, cause any issues within your existing applications. Oracle 12c also introduced this new function called approx count distinct function, which is very similar to when you do the count for distinct records. It is more efficient than the current count function. You know, it would be a lot faster with the negligible deviation from the exact result. So it actually selects the approximate number of unique records, but it goes faster, you know, when you have a huge table. Again, it doesn't give you the exact number, but you know, it will give you very close to what you use when you use the count distinct function. So this is something there, and I think it might be utilized a lot with the data warehouse kind of applications, so it might be very useful there. Next feature Oracle has introduced is exporting views as tables. This is really a neat feature. This feature basically extends the functionality of the data pump, and then it allows it allows to export views as tables. So you have to use a new parameter called view as tables when you're exporting. It will export your table definition and the data as well. It will export dependent objects like, you know, constraints on the view and grants on the view. I think it's very useful to export set of data from tables, very complex views. So here's the syntax. You know, export db username, password, blah blah. So view as tables, when you use this, it will actually export as a table. Similarly, you can import the exported view as a table back into your database. There are with Oracle 12c release 2, we are currently at release 1 right now, but with release 2, Oracle made some changes to the name, the size of the names or the length of the names for the tables, views, triggers, columns, and so on, up to 128 characters long from 30 characters. So this feature is enabled in release 2 version, and you can look at oracle.com for more changes to release 2 versions. So that's it for the part 1 for Oracle new features for developers. The next part will be new features for Oracle DBAs, which I'll actually put it out in few days. Thank you.